multiple energy sources, loads, or a conversion of them, which ultimately result in an efficient operation. So, when we talk of hybrid energy sources, we are talking of three main components. Now, in an electrical system, you have an AC supply, you have a load, and then you have a DC supply. Now, the conversion of all these is what we are going to be talking about. So, one product that you see here is called the AFG. The AFG is a front-end device which is connected to the grid, which basically converts your AC voltage to a DC voltage, okay, in various forms. You have something called a VSI, which is a conventional inverter, which converts this DC to AC. Now, all of you are quite familiar with inverters because they are used for variable speed drives. Okay? And then you have another device called as a DCU, which is a DC to DC converter. Now, let's go a little bit deep into it to see where they can be used. Now, as I told you, the AFG is something that is used for in a grid side. So it takes a grid voltage and converts it to DC. And in combination with something, you can find applications for it. Now, why do we say it's a grid converter, or why do we say? Because it is connected to the grid and it is used to pump probably energy back to the grid. Now, when you're doing anything to the grid, you need to maintain a certain amount of grid standards. For example, when you connect to the Singapore grid, the electricity board here has certain conditions, what you have to fulfill. So each country has its own grid rules. So we can follow the grid rules with that product. What are the different ways in which the AFG can be used? This is the most conventional usage of the AFG, where it is used along with an inverter and it drives a rotating machine. Okay. I've written here it is similar to an AFE. Let me give you a simple example. For people who have been used to going to the port, you use an elevator where you have the load which is going down. Now, what happens when a load is going faster than what you want it to go? There is a braking involved. Now, when we do a regeneration braking, we are putting the energy back into your main supply. Okay, and that is what it happens here. Okay, and when you feed it to your network, you of course have to take care that it follows the grid standards. You just cannot pump it back into the field. So that is an application, a typical application. You have the downhill conveyors, you have cranes, you have elevators, for example. These are regenerative applications. Now, another example is, this is quite popular example. What I tell you is, imagine you have a windmill. Now, the windmill, can you control the speed of the windmill? You cannot control the speed of the windmill. It's completely controlled by the wind power or the wind force. Now, however, the windmill has to generate energy back to the mains. So then what you do is, you have a system like this, where you do not actually control the speed of the windmill, but you use this VSI to generate a certain amount of DC based on the windmill rotation. And that DC voltage, we use the AFG to convert it to mains and pump it back into the network. Now, how much power goes to the network depends on the speed of the windmill to the network. So the windmill is quite a standard application, very popular worldwide for many years. But what we have done for a windmill manufacturer is something different. Now, the windmill manufacturer wanted to study what happens to an electrical system when the windmill is operating. For example, if the windmill suddenly shuts down or the windmill speed is varying from later. But in this case, what we went for a physical system called as an emulator. So in the emulator, what we have done is we have replaced the windmill itself by a gas engine. The other systems remain the same, but the windmill is replaced with you can simulate or you can emulate how it works on a grid. So this is what has been done, very simplified drawing. You can see that what we have supplied is 800 kilowatt generator and a 800 kilowatt AFG system. So depending on the operation of the gas engine, you are controlling how much energy goes back to the grid. So now the windmill manufacturer can send public grid, it makes a grid. Now imagine you have marine systems where you don't have a public grid. You are creating a grid by yourself to supply to the other equipment. I want to give you an example. Now, you have the port here where you have hundreds of ships coming in. And do you know that ships have either 50 hertz or 60 hertz operation? Now, what happens when a 60 hertz ship comes to the Singapore port? Your supply is 50 hertz. What do you do when you have a 60 hertz ship come? Traditionally, they've been using generators to generate the 60 hertz. But nowadays, you have a lot of environmental clauses which says that you cannot use generators, you cannot pollute the environment. So then what we have done is, we have created a grid converter application where you convert this 50 hertz to 60 hertz and you create now a grid by yourself and supply it to equipment. Now this is a real life case what we did in Sweden, where big ships of around 5 MVA power rating used to come. So we provided a system such as this, where the ultimate result is that you can have a total of 3 ships can dock in with 2 in 50 hertz, 160 hertz, or 2 in 60 hertz, 150 hertz. And the 60 hertz is generated by us. Okay, so we have created the grid now. So when you create a grid, you have a lot of issues to it. For example, you have motors starting, you have motors stopping, creating a grid. And all this can be done on the fly, which means that through a software program, through your communications, or through a hardware switch, you can shift between creating a grid, or you can take energy to the grid, or you can work as a normal drive. Now, till now you saw about the AFG being connected to an inverter, okay? But let's take a case where it's connected to a battery, okay? Even it's a very popular application where the AFG is connected to the battery. So the AFG can feed voltage directly to the battery, and whenever you do not have a supply, you can take from the battery and feed it back to the network. Now, you might wonder, where is this application being used? One example is in Europe, you have different tariffs over the day. So during the daytime, the tariffs are more expensive. In the night time, the tariffs are low. So what they're doing is, in the night time, you charge the batteries, and whenever you have the peak charge, you discharge from the battery into the network. So you use this device as a sort of a money gainer. Okay. So this is called as a load shifter. So you have peak load at one time. At that time, you don't utilize power from the grid, you push power into the grid, and when the load is low on the grid, you charge your batteries. Okay, that's a power shift or a load shifting application. The second component on the 3 components I showed you was the inverter. Now the inverter, I will not talk much. It's a standard inverter. So it's a DC to AC converter. You can use it, for example, to control standard motors in all your applications, whether it is a HVAC application or pump, fan, you can use it. Plus you can use it for all the various other operations. For example, the last operation is where it is used for shaft generators or windmill supplies. But then I will talk to you more on the very interesting concept, the DCU, which is a DC to DC converter. Now you might ask me, why do you need a DC to DC converter? Okay, you need a DC to DC converter because we do not control the batteries. Battery is normally controlled by a battery manufacturer who can give you different ratings of batteries. His battery voltage could be different, while your voltage, what you can generate, is different. So then you use this device in between to basically interface between the voltage you can generate and what a battery voltage can generate. It's not just battery. You can see an example later on where there's also a fuel cell coming into it. So this is a typical case. So what you do is, when you have a normal supply, when the power supply is available, the grid generates a DC voltage. Now in this case, I'm calling this as a higher voltage and the battery is at a lower voltage. So when you have a grid supply, I'm generating a higher voltage DC. I step it down to a lower voltage DC, give it to the batteries, but at this time I'm charging the batteries. So you know that when you charge the batteries, there is a certain amount of control to be done. You need to charge the amount of current goes into the battery. So then we do a charging control. Now what happens when your source is gone? When you lose your supply, The battery then pumps back energy, and through the AFG, it gives it to the grid. So you can have the same way. Now this is a case when you have a low voltage battery. Now imagine you have a case when you have a high voltage battery. You can do the same thing. You can then pump the low voltage to a higher voltage, feed to the battery, and when you don't have main supply, the battery can then give supply to the mains. I'll show you one example what we did. The examples I'm showing you is what we have actually implemented. So here you have a case where you have a low voltage generator. It's a 400 volt generator, but you need to feed a high voltage to the grid. So what we do is the generator generates 400 volt. We convert it to a certain amount of DC, and then we use the DCU to convert it to a higher voltage DC, and then we use the AFG to convert this high voltage into the grid 690 volts. So this is an example where we have used an AFG and a DCU system. We also do much smaller systems. For example, for home use, we can do a system completely as a single module system, which if required you can parallel it. There is a lot of regulations on environment around the world, and in Europe now, the regulations are that all passenger river ferries cannot operate on diesel or generators. So you need to be hybridized or electrified. So then we have done a lot of jobs in Europe on this. This is one case. What we have done, we have used all our systems here. So when the ferry is at the port, you have the main supply which comes in. With the AFG, we generate a DC voltage. The DC voltage is going to a propulsion motor if required. It also goes through your DCU to charge a battery. Now if you notice the battery voltage is lower, the battery has not been decided by us. The battery has been decided by the ship owner. So we provide the DCU to change this higher voltage into the lower voltage required for the battery. Now imagine what happens when the ship goes off, when it moves away from port. You don't have this supply anymore. Then all the supply comes from this battery. So the DCU now converts this low voltage to a higher voltage DC. The VSI converts this DC into the propulsion motor. You also have the AFG converting in making a grid here, and the grid is now feeding all the other supplies. Okay. You also have a solar panel in between here. So when it is sailing, the solar panel can also generate some amount of voltage. So this is a system where you can see that we have everything here. We have a DCU, we have the AFG, and we have the VSI here. Very, very commonly used in vessels nowadays. It's a little bit more details on how that works, but we also have done something where, is hydrogen getting popular in Singapore? Hydrogen cars and hydrogen in not yet, okay. But it's a big thing now worldwide because it's clean energy. So the hydrogen fuel cell on an experimental basis was used on a cruise ship. So these are the hydrogen fuel cells which is generating a certain amount of voltage. So we use our DCU to step up the voltage and give it to a competitor's converter to feed it to the mains. So this is an example where a DCU has been used to change the voltage level. So if you take, I've shown you an example of what happens in a marine system where you have everything. You have the VSI, you have the DSU, you have the AFG, but you can have similar systems even in a process plant, for example. If you have a system where you do not want or you cannot afford to have your plant stop for any purpose and you're worried that the grid can fail, you can have a battery backup with a DCU and a AFG so that in case of a power supply dip, the battery takes over, creates a grid, and your process plant can run. Okay? So the applications are enormous. You can use it for in home uses, you can use it in process industries. Marine, of course, is the biggest usage because it is always away from shore. You don't have the shore supply, so you're away. But the applications are enormous. And that is where hybrid energy system is becoming very popular.